Esta conferencia comenzará a grabarse.
So, welcome to this new session of the European Alliance Against Coronavirus. As always, you must know that we are recording this session and that if you keep with us, you are accepting that the session will be not only recorded, but also published on both the channels of the European Cluster Alliance and those of the ECCP, the European Cluster Collaboration Platform. Today we have a very important topic for the sovereignty of Europe. The European Union is the state and future of the electronics ecosystem. You know, it's a very hot topic because we are having big problems in the supply of several microelectronics components for, at least here in Spain, mainly for the automotive factories, but not only for them. So it's quite important for us just to understand what is the current situation and where are we going, and how can we improve our resilience on that side, and how can we help the European market to better afford this kind of situation of challenges in the future. And in order to speak about it, we have with us again Ola Sredin, okay, from Mobile Heights in Sweden. Thank you very much, Ola. And again, Ola will moderate the session, so it's good news for me and for you, that because Ola really knows what he is speaking about. So Ola, from now on, the floor is yours. Thank you.
Thank you so much, Antonio, and thank you for the opportunity to present here today. Maybe, Nina, if you can give me the presentation rights, I can present. Okay, let's see. So here we are. Good morning, everyone, and thank you for joining. Today, I have been given the opportunity to moderate this session to talk about the important topic that Antonio introduced. And today we will present from three different cluster organizations, and we are all members of the Silicon Europe, the European Cluster Alliance for Innovative Electronics and Software Technologies. So myself, I'm from Mobile Heights, and then we have Olivier from Pole SES, and then we have Fabrizio from MESAP, also joined by Petra from VDI-VT. And the idea here is to kick off with Olivier, who will talk about a little bit about the overall state of the European electronics ecosystem. So I don't know, Olivier, are you with us?
I'm here. Hola.
Perfect.
Can you hear me?
Good morning. Welcome.
Good morning, Hola. Good morning, everybody.
So I think, Nina, if you present, I don't know if Nina, if you present the slides or if Olivier.
I have the slides, so okay.
Okay, the floor is yours.
Okay, good. So can you see something?
Yes.
Is that good this way?
It's great.
Okay, thank you very much, Ola. Thank you to give us the opportunity to talk to this session on the microelectronic topics. And as Antonio said at the beginning, it's a very hot topic at the moment. So I would like to give you a quick short overview of a part of the whole electronic, which is the semiconductor market, and what is our view on the current European market. First of all, let me give you a few words about who is SCS. SCS is a cluster. In France, we call that Pôle de Compétitivité, and we have been labelized by the government in 2005. So we have a long experience. We are focused on the ICT industry and mainly 4 topics: the microelectronics, which will be the subject of today, the Internet of Things, the digital security, and the AI, artificial intelligence and big data. So we have almost 300 members. A lot of them are small startup and SMEs, and we have a certain number of large groups. We are based in the south of France, in the Côte d'Azur and the Provence region, which is, by the way, a nice region if you want to come to see us. A quick focus on the microelectronics part, on our 4 parts. So we have more than 50 companies, 3 research labs. We have made a lot of projects, European projects and national projects funded by public funding. We have a unique, 2 unique mutualized R&D platforms that can help all the SME to have access to very expensive microelectronic equipment. And the idea is to help them to start their business without investing in, without having massive investment in equipment. So as you can see on this slide, our ecosystem is more focused on fabless and IP company with, of course, foreign companies that have put some R&D offices in the region. So that's it for the quick introduction of SCS. So let's start with our journey on the EU semiconductor market. A lot of the elements I will use today are coming from a very interesting study that has been made by ACA, the Semiconductor Industry Association, that some of you have seen. So to start with, you know, this semiconductor, this chip, is a very small thing that is expensive, truly globalized industry, and which is really the engine and the heart of the global economy. So why expensive? As you can see on this chart, the semiconductor industry is a very expensive industry because it uses a lot of capex. This is the top capex, so investment, capital investment industry amongst all the industry in the world. Just up the utilities company with a lot of investment in manufacturing and equipment, but it is also a sector which is the most R&D intensive. So this is why this is an incredible industry with both, you know, capex and R&D investment. So expensive industry. This is very globalized. I'm sorry this picture is not very clear, but you can see here the different elements of the value chain. On the top, you have what is related to the R&D and the different components of a semiconductor. The tools to design a chip, all the logic semiconductor, or the digital analog semiconductor, and the memory. And on the bottom of the slide, you can see which is related to the capex, what I mentioned before. And the color here relates the different regions who are the share of the different value element of the value chain in the different regions. So as you can see, we have all the color. Unfortunately, the black color, which is the Europe one, is a little bit too small for me and for all of you, I guess. You see that basically the US industry master the R&D part, while the Asia Pacific industry master the manufacturing part, the capex part. And but at the end of the day, every element of the value chain is dependent from a region to another. So it is not so obvious to create, you know, total independency amongst one continent. All continents depend from the others. So this is really globalized, and I'm not sure that all the industry are the same way. Then third part, at the heart of the global economy, as you can see on this chart, the semiconductor part, which is on the bottom, is really the foundation of all the electronic system that you can have in the world today. And as you know, electronics is really spreading a lot of different sectors. the automotive industry, the industry in general, the telecom industry, the consumer industry. It is difficult to not find an industry now with the semiconductor piece. So as you can see, this small piece is really a strategic piece on the today global economy. Let's look at the EU. So EU, we are a small player, really, on the semiconductor industry. So some figures, in 2010, the world market was around $350 billion, and the top 15 semiconductor company represent 53% of this global market. This was 2010, and you can see on the left, we have the three major players in Europe, Infineon, NXP, and ST Microelectronics. They were representing close to 5% of the world market. And you see their position on the ranking. Let's have a look on the right side, 2020. The world market is close to $440 billion, which is a growth of 27%, basically. But the top 15, as you can see, is now 81%. This shows, I think, what you all heard about, the consolidation on the semiconductor microelectronic segment is very strong. And the good news is that our three players, even if their ranking is not really growing so much in the top 15, they are growing faster than the market because they were representing more than 6%. I have to move this. Okay, yeah, close to 7%, and they have grown something like 70% over the 10 years. So basically, we are still small. We have not a lot of players when you see on those slides compared to the US and Asia Pacific region, but we are growing fast. And how these European semiconductors are positioned and working? So on the next slide, you can see here a graph that shows the repartition, the split of the semiconductor over the different key vertical markets, from mobile phone to automotive. As you can see on this slide, the majority of the semiconductor usage is on consumer markets, if I take mobile phone and PC as consumer market. And 22% are on industrial market and automotive market. On the bottom right, you can see a chart positioning the vertical industry share in the world. And as you can see, Europe is leading the market on automotive, 27%, on industrial activity, and also on healthcare activity. And what is interesting is that you can see that this industry represents the 22% of the EU chip, worldwide chip split. So the last slide on the last graph on the bottom left side show the position of those EU semiconductor players on the automotive industry. So the conclusion of this slide is, first of all, EU semiconductor companies are good with the market where the customers are based in EU. And I think it's some things which is a good sense. You are better when you are close to your customer. And all of you know that we don't really have a PC industry. We used to have a good mobile phone industry, but it is not more present. So, and there is a logic on that. EU semiconductor companies are working with their customers who are close to them, and this is this market where EU is strong. And the other important information is that those industries are not using at the time being very advanced technology for semiconductor. They use, I would say, standard nodes. In this industry, we use the terms of node, which are between 50 and 180 nanometer. And this is more or less where we have still some foundries in Europe. So we are well positioned on European industry markets, but these industry markets are not using a lot of semiconductors. So if I take a view on the traditional SWOT analysis, I can share with you our views on the microelectronics. So we have good players that are well positioned to serve the EU industry. We still are strong in IP thanks to ARM, although we know that ARM could pass over the US NVIDIA control. And with the equipment, thanks to ASML, which is one of the leaders of the equipment of the microelectronics in the world. And we have some very good leadership in chip security. You know, the three companies I show you, I have showed you before, the ST, NXP, and Infineon, are really leaders in the designing a strong security chip for smart card industry or securing, you know, some mobile phone. On the weakness side, we really are dependent. So our industry that use semiconductor are really dependent on the Asian foundries. You've seen in slide before that close to 70% of the foundry are based in Asia Pacific region. We must recognize together that even if EU has made some investment on the microelectronics, it is too low and too sporadic. We don't have massive investment as we have seen in the past in Asia Pacific, especially in Taiwan and in the US also. Unfortunately for us, except ARM, that will become a US company sooner, we don't have any fabless on the top 20 semiconductor company. And I think we don't have enough EU industry players in the semiconductor. We have some of them, but they are few compared to the other country. And our customer base, which is mainly in the industry, as we have seen, is quite small. Automotive industry represent 20% of the world market and the world consumption of chip. Opportunity, we have strong opportunities, especially as we can see some shift in the demand of semiconductor in the industrial market, automotive market, and the growing IoT market. These markets are requiring some of the technology that are mastered by the EU company, and as you have seen, the EU chip company are very well positioned on those markets. All the green transformation will need semiconductor and electronics, and here again, the EU company are very well positioned. And we note from now a few months a strong willingness of the EU to support the semiconductor industry. We have also some threats. Automotive, edge IoT, 5 and 6G, AI will need at one point some advanced node technology, and those advanced node technology are not produced in Europe. We should be afraid of the massive investment that we are seeing at the timing in US and Asia Pacific to increase their position, so increasing the gap with our EU player and EU industry. And we have seen that in the past. Geopolitical issue can fragilize our position. We have seen that with the Huawei story in the US, where some of our EU players have been very much impacted by not the possibility not to sell to Huawei. Especially, I know that ST Microelectronics has been really impacted by that. So that's our view. To conclude, I would like to share some thoughts with you, and maybe we can have the debate all together. I think the current debate that we have in Europe are mixing two issues. On my point, there is a sovereignty issue. How our industry that use semiconductor is dependent from outside, and this is a fact. Only 8% of the global production of semiconductor is based in Europe. So this is where you have all seen and heard about the discussion on putting an advanced node foundry in the EU. My point here is that do we really need this? Do we have customers that will use in the 5 coming years an advanced node foundry in EU? Maybe, maybe not. And at this point, probably we should let the big foundry to decide if they want to put a foundry in Europe. We should not think about creating from ourselves. But we have another issue in the debate, which is the competitive issue. You've seen all the data that I share with you. We are not well positioned as industry player. we have a very nice semiconductor company, but they are still small compared to the other. And we still not have a market that have a very strong demand on semiconductor, and that you know, creates some volume demand for this industry. Of course, they are already international and they should go much abroad, but the fact is that the European market is not a strong buyer of cheap products. So my view, and of course I don't have the truth, and this is what we can debate together, is that we can't, you know, pursuing several rabbits at once, and maybe EU decision maker and all of us should focus on some point. And the point I would like to focus on my side, and that I can share with all of you, is that we should increase massively the R&D and the design investment on our fabless that are, even if they are not all fabless, but on our three main players especially, and the others. We should find some strategy to enlarge the number of fabless in EU. We don't have enough fabless, and when we have small fabless that are startup, they don't find money to invest in their capital. This is very capital intensive. You have seen that. So this company, if they want to launch a fabless activity in EU, they need a lot of money. And to be really frank, we see that the private venture capital are very, you know, absent on this segment. And we should accelerate the digitalization of the EU industry to increase the demand of semiconductor. And on this side, I think EU has taken the right decision with all the Digital Europe program and the Digital Innovation Hub. So this third point, to my view, is on the way. But the two first points need more attention. So that's it for my point on the global view of the semiconductor market. I hope it has been useful for you. And Ola, I leave you the board once more.
Thank you so much, Olivier, for this insight into to where we are today. And for me, it's an eye opener really to see the trend that for the last 10 years and where we are today. And you have some recommendations. I think I can see that. What do you think would be the most important thing for us to do? You had 3 points at the end where the so-called rabbits. We can't chase all the rabbits. We have to pick perhaps 3. I mean, how do you do that? How, for instance, do you increase investment in fabless? Today?
I think that's a good question, Ola, and that I'm happy to have your view also on that. But I think the first of all is the venture capital industry needs to have more funds available to this industry. I don't know what you see in other countries in Europe, but especially in France, which I know well, it is very difficult to find investment for venture capital in semiconductor companies. They are afraid of this industry. Mainly because they are used to have a good and short return on some other industry, and the semiconductor industry, the return is on the long run. There is also another point we're seeing is that, technology and semiconductor industry is not so much attractive as it has been in the past for young people. When they get out of school, they prefer to go to finance or other luxury business, or I don't know, other service business, and they don't really go straightly and demand to go to the microelectronics industry. So we need to, have a program that will make the interesting attractiveness of this industry to the young people, and that they would like to create more startups. You know the story. You need to have 100 startups to have one that will be big at the end of the day. So I would like to see a program, and I know EU has made some, already some interesting program, with the accelerator, the SMA instrument in the past, and with some capital investment funding, but it is not enough. We need all collectively to increase that and to promote the creation of startup in fabless.
Yeah, I tend to agree. Thank you for those wise words. We have a question from Jaime. Do you want to put it yourself, Jaime?
Yes, thank you very much. It's a question to Olivier. Olivier, thank you very much for your very interesting explanation. As you know, the President Biden is visiting now Europe. And how do you think that this opportunity could be taken to try to reinvent a new strategic alliance between the US and Europe on the electronics ecosystem? Thank you.
That's a good question, and I'm not sure I have a real answer on that. You know, if I give you my view, I think everybody's talking about Asia Pacific and the competition with China and you know, Taiwan and the others, but we are also in competition with US, and you've seen on my slide that they are mastering the R&D side, and I'm not sure that President Biden is really want to share that. So President Biden will probably ask, you know, European company to help US to more control the technology supply to China, and so probably they will ask, you know, our chip leaders to not to supply too much technology to China. So probably we can ask something in exchange to US that probably they increase more the investment in our European market, you know. You know, there has been some discussion that Intel could build a big fab in Europe, and I have heard that there's been discussion in Germany. So maybe we can ask Mr. Biden that we are ready to play with him, but please help us to have Intel putting a big fab in EU with the American money and not the EU money.
Yep, that's. I think that's a great discussion to have, and for sure this is front and center of the policy discussion. It's as Antonio mentioned earlier, it's one of the key issues for Europe today. Do we have any more questions from the audience to Olivier? No? Okay. Thank you very much, Olivier, again and stick around if you have time. Maybe there will be some more questions in the end. So thank you. Now I think it's time for us to move on to the next speakers, and we will start out with giving the mic to Fabrizio, who will tell us about the very interesting European project.
Yeah, thank you, Ola. And yeah, first of all, I want to thank also the European Cluster Alliance for this occasion. I will give you a short introduction of MESAP, and then my colleague Petra, she will show you the work carried out for the European electronics ecosystem under the 5E project. So thank you again. So if you can move with the next one, please. Yeah, only to say that MESAP is one of the 7 regional innovation clusters in Piedmont region. We were born in 2009, and we are focusing on smart products and smart manufacturing. We are also an association of more than 270 members, of which about 80% are SMEs. Thank you. In the next one. Yeah. In this chart, there are some our members' industrial sectors. As you can see, we work on very horizontal approach, let me say, but I want to underline only in this occasion the first 3 markets, because that are justified by the fact that Piedmont is have a strong automotive prevalence. She's one of the most productive region in manufacturing, and also we are a worldwide aerospace district. If you had the percentage, the total will be around 300%. That means that our members work on average on 3 markets. So the next one, please. Yeah, here there are our goals. You can read, of course, but I want to underline. Let me say the second one, the technology transfer, because also connecting research entity and private companies will mainly helps also the SMEs to get in touch with each other and with the RTOs to help them in innovation projects. Also, yeah, we work on exploring new opportunities. We work with at intercluster level because we born as regional cluster, but we collaborate on national and European levels. And we constantly analyze the innovation update in order to involve leading companies, adopt technological and market megatrends, and lobby decision makers. Next one. Yeah. In this chart, there are some of our international technological association and some of our European projects in which MESAP is involved. Unfortunately, I can give you a full presentation of each association or project, but let me say that we are proudly member of the Silicon Europe Alliance that invite us also in this occasion through the European Cluster Alliance. And we are part of and member of the European Technology Platform on Smart System Integration, so EPOS, for which we manage the Smart System Integration trademark. In this occasion, we want to underline regarding our European project, the 5E project, the project that aim to federate the three European electronics ecosystems in nanoelectronics and flexible organic and printed electronics and electronic smart system. And so before to pass the floor to my colleague, there is also the last slide that are only our channels. If you want to get in touch with us, there is also, sorry, the QR code, but I think that the presentation we uploaded through the website, and so that you can take it also later, of course. And sorry, maybe I was too fast, but I don't want to waste time and give the floor to my colleague, Petra Feiler, to introduce the 5E project. Thank you so much, Ola, and also thank you again, the European Cluster Alliance.
Thank you very much. Thanks a lot also from my side. Next slide already, thank you. 5E project, as Fabrizio already mentioned, today our idea is to present a bit of information on the meta roadmap that we developed, which has functional electronics at the center. Next one, please. As Fabrizio also mentioned, 5E is the coordination and support action funded by the European Commission in Horizon 2020 framework program. It has a focus on hardware electronics, and in particular we look at how the three areas of nanoelectronics, flexible organic and printed electronics, and electronic smart systems could work together and combine their strengths to exploit new innovation opportunities for electronics. We have a strong focus on, next slide please. We have a strong focus on EU industrial competitiveness. We are aligned with the, I think already mentioned, EU strategy on electronics, with the issues of sovereignty, manufacturing capabilities, large-scale investments, the co-design aspect, and the skills development. We are in line with Horizon Europe clusters and the areas of intervention, as well as with the Digital Europe program, and a strong focus of our mission is on making visible the important role that electronics plays in digitalization of European industries. To operationalize all this, we developed a joint vision and a meta roadmap that I will present a bit later, and also federating basically these electronics communities, so with a strong focus also on outreach and visibility activities. We are 7 partners, and we are supported by 37 associated partners representing clusters, ETPs, also industry and regions. Next slide, please. This is to show that we have achieved already quite a good impact. Our notion of functional electronic has been taken up in Horizon Europe Cluster 4 work program, in the ECS SRIA version 2020 and 2021. And also we have set up a working group in EPOS, the European Technology Platform on Smart Systems Integration, on green electronic components and systems, which is an outcome of one of our vision papers. I will say a few words on that later. Next slide, please. We have basically 9 key deliverables. One is a big catalog with 39 opportunities, 1 page for each of these opportunities, and I encourage you to go to the website and have a look in depth. Then we have developed the mentioned joint vision, which is based on the concept of functional electronics, 4 vision papers, the meta roadmap, and a digital showcase that is managed actually by MESAP. Everything available on the website. Important to mention, and you can already go to the next slide, is that we have involved, I think now probably 300 stakeholders in our consultation workshops, in the different feedback gathering exercises, workshops, etc. We have been looking, as I said, on the 3 electronics areas and with a strong focus on the interfaces between these 2 at the convergence. We started with functionalities in order to be independent of technology. Sorry. I continue. Functionalities like actuating, sensing, computing, signaling, energy harvesting. And we have a methodology that has a combined top-down and bottom-up approach, and that brought us to the 39 opportunities, and then to the vision and the vision papers, and finally the meta roadmap. Next slide, please. We noticed that at the interface and at the convergence of these areas, there is something that we call functional electronics that has the potential of differentiating and of giving a competitive advantage to European electronics industries. We named it, as I said, functional electronics, and we put it at the center of all the further work. So this functional electronics has 6 features, and I will briefly go through them because they will play a central role also in all of our recommendations in the meta roadmap. So we see that there's a shift from physical to functional integration, and a move towards these cognitive functions. Then to base all developments on novel substrates and systems, that's a development we have seen. We need to put eco-design approaches at product, process, and business model levels at the center of attention. This also brings with it real-time capturing and management of multi-physics data and contextual information. We see more and more that networked and autonomous operations and that the combination with software solutions move forward. And in the end, all this serves the seamless integration in everyday objects and applications. Next one, please. As I said, we put this functional electronics concept at the center of work, and we defined 4 areas that deserve particular attention, also based on the 39 opportunities that we found. And we clustered those in 4 vision papers. One is on circular economy, another one on energy, third one on autonomous operation of machines, and sensing is the last one. All of those also looking at societal challenges. Next one. I start with the one slide on the circular economy vision paper, and basically you see here that we looked at the green and the digital transition, knowing that one cannot work without the other. In particular, we cannot have more and more digitalization, more and more components without looking at the green aspect, the sustainability aspects. That's why our recommendations focus around ensuring that sustainability is put at the center of all solutions we develop in electronics, and also to have a proper and meaningful regulatory and legislative framework to accompany this transition. Next slide. The other vision paper on energy looks at both sides of energy in combination with functional electronics. One side is to minimize or optimize power consumption and to look at how we can power electronics with management, with energy harvesting, storage, and low power electronics. And on the other hand, what functional electronics can actually do for the energy sector, for the energy system. And here, in particular, we look at power electronics, converters, the whole energy management system, smart grid, etc., and the wireless power transmission. Next slide, please. In the autonomous operation of machines, we have started out from the autonomy levels of automated driving, and we are convinced that we will need more and more functional electronics to enable these autonomous operations of machines. And the recommendations focus around the first two autonomy levels on edge AI solutions for that, and also on centers for knowledge transfer, living labs, and again, a sort of legal framework and some integration strategies. Next slide, please. The sensing was a bit broader because, yeah, you probably all know that sensing is everywhere, is needed everywhere, and that deserves particular attention. So we noticed that in electronics roadmaps, there's strong focus on AI, big data, smart systems, sensor swarms, trillion sensors. On the other hand, we noticed that there's the sensing landscape that shows us we are moving from reactive towards proactive sensing, and we have to deal with more and more fast-changing conditions and occurrences. There are some technical challenges related to reliability, accuracy, for example, situation-based awareness, and quite a few other issues. And we look also at distributed sensing solutions with a large area coverage, with sensing integrated in a lot of products that are networked or not. And finally, it has a strong cross-sectorial application focus with all these smart grid, infrastructure, self-driving cars, smart cities, so all urban monitoring, IoT, safety. Next slide. It's all the issues that we developed in the vision papers we translated into recommendations, issues to be addressed. So basically like call text to be used by the European Commission or regional and national funding programs. We looked at the stakeholder groups, how important, how urgent these measures are. We proposed funding schemes, and we addressed the technological and non-technical barriers. Next one. There were 45 of them, but we choose 15 altogether, which are important and urgent. You can already go to the next slide. Thank you. And these are the 15 recommendations along the 4 vision papers, 2 for circular economy, I mentioned those. Then on energy, 3 for the right side of the slide, which look at powering electronics, and 2 looking at the other side, functional electronics for the energy system. Then for the autonomous operation of machines, we have the 4, I think I basically mentioned those already, and for sensing another 4. And those for sensing maybe deserve saying that they focus around application areas. So one's on self-driving cars, another one on environmental monitoring, then one on medical applications, and the last one on IoT applications. Additionally, we have found that there are 2 more things that we wanted to recommend. One is to look at the reliability of functional electronics, and the other one is an opportunity to translate our methodology or to apply our methodology looking at the convergence of electronics areas to other technologies, key digital technologies. And of course, one that comes to mind is integrated photonics, also quantum computing, quantum technologies might be one, and we have proposed to do that. Next slide. And I'm nearly done, sorry. This is the digital showcase that I mentioned, and I'm sure that MESAP already promoted this in your network, being a member, but nevertheless, to say that everybody who is dealing with or who has members working around electronics, please look at the showcase and maybe promote and incentivize a bit that people, especially SMEs, upload their showcases here. It's really a great opportunity for increased visibility. Thank you. I think this is it, a list of links that you will get, and basically go to the website, have a look at all the content that is there. And with the last slide, next one, we say thank you and are open for questions. Thanks a lot.
Thank you very much, Petra, for this insight into the 5E project. And for sure, I looked into the showcase, the 5E showcase webpage the other day, and there are some really interesting companies and the use cases on that one. Can you mention one or two that stands out from the crowd?
Yeah, that's an easy one. We ran an award contest actually, and there were 3 winners, and one is particularly mentionable. It's actually a textile solution, integrated electronics into textiles, which has sensors integrated and helps prevent attacks to women. So they wear this, they know when there's touching or when they're critical zones. So yeah.
That's a great example. You do a great work to showcase the innovation, not the least, as one of the things in this very interesting project. So, any more questions from the audience? No. Okay. Then I think
the link already. That's nice.
Yes, if you want to discover more about some examples of great electronics innovations, like the Lilith product that Petra previously introduced, you can see more detail also in these news put in the chat, and of course on the digital showcase. Thank you.
That's great. Thank you very much. Then I think we move on in the agenda, and now we have heard from Olivier describing a little bit the macro view of the state of the European electronics ecosystem, and we have heard about a very interesting European project that looks at kind of the next level of integration above microelectronics, using the microelectronics. My thought with my part of the speech today is really to deep dive a little bit and look at a few examples of what we are doing in our corner of Europe when it comes to this. But first, just a few words about Mobile Heights. So we are the ICT cluster in southern Sweden, roughly 130 members. We do the usual stuff, so to speak, that cluster organizations do. What are we good at in our part? I will come to that. So I put here on the slide, Bluetooth was invented here, in fact, in this part of Sweden. We are really strong in radio communications as well. I will come back to that. IoT in general, embedded systems, a lot of knowledge about that. Image processing, biometrics. We actually have 2 world-leading biometrics companies in the area. AI, machine learning, of course, and cybersecurity is also where we have a lot of knowledge mass. So I will tell you a story about how you can actually kickstart a cluster. How can you create a new knowledge cluster? In our case, it was really about the company Ericsson deciding to put a research and development site here in the south of Sweden. Most of the R&D back in the 80s was going on in mid-Sweden, around the Stockholm area. But then they decided to put a large R&D site in the south. And why did they do that? It's because we had already established a very strong university, technical university here in the area, Lund University. And as it has played out, this symbiosis between industry and academia has given us a really strong position in radio communications, and also recently nanoelectronics, in fact. and I will come back with some examples of that. So now we have a large cluster of expertise that really stems from the telecom industry, and we have R&D sites of very large corporations here today, such as Sony. We have ARM, a large R&D site present here. Volvo Cars is here because they see the need to dip into the knowledge that we have in computer science and electronics. Also large.
I'm sorry to interrupt. We do not see a presentation, or at least I do not see a presentation. I see your face and a white board.
Oh,
Yes, me too.
Let's see.
Yes, it's true. Yes.
Can we perhaps, yeah. What happens if I want to do like that? Can you see something? Can you see me now?
Yes, but no, not really. The presentation is kind of with a big focus on a white area.
Ah, okay. That's really strange. Sorry about that.
Now you are center. Yes, it could be.
Yeah. Okay. So let's see if it works when I move on. So the intention here is to give you a few examples of companies, a little bit smaller companies that come from this cluster of knowledge that the big companies provided this part of Europe with. And the point here that I want to make is that this is one region in Europe, one of the region with this kind of cutting edge knowledge. And there are many others. One of the companies, Antonio, can you see the slide now?
Yes, I think it's right now. Yes, I think so.
Okay, great. So one of the companies I want to mention is Sigma Connectivity. And that is actually the hardware expertise from the mobile phone industry that is now in a consultancy company. And they are making solutions for all the big companies around the world today with the knowledge that they have acquired from the mobile phone industry. So yes, the mobile phone industry might be more or less gone, as Olivier mentioned, from Europe. But on the other hand, we still have the knowledge, we have the engineering capacity here, and we put it to good use. You can probably recognize in the corner there some home automation solutions developed by this company. Spotify put out what they call the car thing the other month, also designed by Sigma Connectivity. They make a bunch of stuff. They're also into medtech, like the Koala Life solution that I put here as an example. So that is one example of how you make use of the knowledge cluster. So what we have here in Skåne and in particular the university town of Lund, we have a very strong knowledge around telecom, but also material science, and that is the very important to for new microelectronic solutions. And I will give you actually 3 examples of microelectronics companies that have been spun out from Lund University. Nordams, Aconair, and Xenergic. First example, Nordams. What do? Well, they are addressing the ever increasing need for speed. So we all want fast multimedia content at our fingertips, right? And we will probably soon have virtual reality solutions in our glasses, and all of that will be wireless, of course. So we need to cope with ever higher frequencies to cope with the data rates that these new applications drive. And what Nordaps, what they identified is that existing semiconductor technologies are not really viable at these frequencies. The existing solutions are really expensive, if at all available. So what they did was they invented a new type of transistor. So they went from I should say 2D a 2D solution to a 3D solution by using nanowire technology. So that's a merge between the nanomaterial, the nanoscience that is available at the university, together with the more shall we say traditional microelectronics research. And this new type of transistor that now enables a huge leap in frequency. So it's the smallest element of a microelectronic solution that really can unlock new use cases. So that is the first example I wanted to mention. The second I wanted to mention is Xenergic, also spun out of Lund University. So we have all noticed that our phones and laptops get very hot sometimes, right? So something needs to be done because we want more and more processing power in our devices. But that inevitably means that with the present technology, power consumption goes way up. And that manifests itself with short battery time and hot, really hot devices. Problem, not the least in the summer. Well, Xenergic, they have developed a solution that can decrease power consumption by a lot in system on chip solutions. And they are already on the path to, getting this out to a large scale production. So they have already agreements with some of the large semiconductor companies. And they recently, for instance, they signed a contract with Bosch Sensotech. You might have noticed that Bosch is opening a new fab in Dresden this week or this month. Tapping into a little bit the discussion we had earlier that Olivier brought up, that we are low on fab capacity in Europe compared to Asia and America. And of course, opening one new fab will not change that solution dramatically, but it's one sign of the trend that we are actually growing the industry now in Europe. So Xenergic, very good example of a startup, now a scale up, that is putting new technology to the market. The third example I wanted to bring up is Aconeer. They are doing what is called a pulse coherent radar chip. So it's a 60 gigahertz microradar with a 1 milliwatt power consumption. And that is the result of more than 10 years of research at the nanoelectronics group at Lund University. So the interesting thing with this technology is that you can basically use it in all parts of society. You can find use cases where you need a small and reliable microradar chip. So for one such use case could be, for instance, to detect if there is somebody in the car. Imagine, I mean, now we're getting into summer. Sometimes when you leave the car, perhaps you forget that you have a pet in your car. Wouldn't it be great if you got a reminder in your phone to remind you that oh, I left my dog in the car? This is the type of technology that we want to see everywhere, and Aconeer is a piece in the puzzle to get such solutions in place with this small and cheap radar technology. So I will conclude there, and I guess my point here is that I have now mentioned 4 leading companies, all coming from one relatively small region in the north of Europe. And these are just a few examples of leading edge R&D companies we have within microelectronics in Europe. We are world leading, as Olivier pointed out, in the IP and design, even if the major fab capacity currently is elsewhere. And there is a huge potential to grow European microelectronics industry by connecting our excellence centers that we have in Europe even better than today. So that is the big thing, I think, for us as cluster organizations as well, to do our part in connecting the hotspots we have, the knowledge centers we have within Europe. And the major EU initiatives we see in this sector, I think they will be crucial for success. And the restart after the corona pandemic, that presents actually a huge opportunity for our industry. So with that, I want to conclude. Time is up, but if there are any questions from the audience or reflections, please go ahead.
I will invite Marek to comment on his contribution to
yes,
the chat.
Thank you. I need to go to another meeting, but very quickly, thank you very much for this. I just want to highlight that electronics is one of the 14 ecosystems. It is now very visible. And as well as you can see in the chat, there are initiative, and it is very, I don't want to it's not a fashionable, it's a need. It's a need for our open strategy independence as Europe. So there is big right now pressure from politicians, but as well the industry to work together. And you see there is 22 member states decided that they want to work on this. And as well, we as European Commission, we will be launching the Alliance of Processors and Semiconductor Technologies. So there is things going on. I'm sorry I have to leave, but I think this is something that we will continue. And the link to the single market report, which we will be updated every year now, we'll have the chapter on electronics, and I think this needs to show the progress we are doing, so that it's not only words but actions, including the investments in this field. So thank you very much as well for the presentations where you pointed out the strengths, weaknesses, and give us more info what is happening in this particular ecosystem. It helps in taking into account your recommendations. So thank you very much for this, and see you soon for another meeting. Thank you.
Thank you, Marek. So congratulations to all the speakers. It has been extremely detailed, interesting, and as you said, Ola, age opener. Okay, so wonderful. I will also recommend you to study carefully the joint cluster initiatives that will be open by the most probably by the end of this year. Okay, you know, the Euroclusters initiative. We think that you have a big opportunity there also to create one Eurocluster on your industrial ecosystem. So that is a personal recommendation from us, but I think it makes sense. Okay, it will help probably you to reinforce the collaboration network that you have created. Okay, Olivier, I see that you are there. Would you like to make a last comment? No? Okay, so thank you very much to all the speakers. Thank you to Ola for organizing it, okay, the session, moderating it wonderfully as always, and I'm looking forward for a new meeting with you sometime in the future. Okay, anyway, you are invited to all our sessions, you know, don't hesitate to come and contribute. Thank you.
Thank you very much.
Bye.
Thank you. Thank you very much. Bye-bye.
Thank you. Goodbye.
Thanks. Bye.